So today we will go through the vectors. On the basis of magnitude and direction, physical quantity are classified in two categories. These are scalars and vector. Scalar are those quantity for describing them we only need magnitude. Direction are not required. Like example, distance, work, speed, etc. And the vector are those quantity for representing them both magnitude and direction are required. For example, displacement, force, velocity, etc. Vectors are represented by an arrow like this. If we give a name to this vector a, b, then this can be written as a, b vector. Vector are further two types, polar vector and axial vector. Polar vector are those vectors which have a start point and a end point. These vectors are directed in the direction of motion, like linear velocity, displacement, force, etc. And the axial vector are those vectors which are along the rotational axis of any particle. These are like torque, angular momentum, etc. Next point is modulus of vector. So what is modulus of vector? A positive number which represent the magnitude of vector is called modulus of vector. We have a vector a vector. Then its modulus can be written as mode of a vector or only a. Since here this vector have both direction and magnitude, if we want to write them separately, then this can be written as modulus of a. This will be magnitude, and for showing the direction of this vector, we place here a unit vector. Let this is n cap. Unit vector are represented by a capped symbol. Let's learn about some types of vector. First is equivalent vectors. Two vectors are called equivalent vector if their direction and magnitude both are equal. Like this vector and this vector. This both have same magnitude and same direction. So they will be equal vector. And unequal vector are those vectors which have different direction or different magnitude, or both are different direction and magnitude. Like these both vector a and b have same direction but different magnitude, so they will be unequal vector. Or these vectors have different direction but have same magnitude, and these two vectors have different magnitude and different direction. So these are three examples of unequal vectors. Third point is negative vector. Two vectors are called negative vector if their magnitudes are same but direction are opposite, like a vector and B vector. These both have same magnitude but opposite direction. They are always parallel. Unit vector are those vectors which have the magnitude of unit and direction is along the given vector. If let we have a vector r vector and we want to find the unit vector of this vector, then unit vector can be found as r cap equal vector r divided by magnitude of vector. For x, y and z direction, unit vectors are fixed and they are along the x direction, unit vector is I cap, along the y direction, unit vector is j cap, and along the z axis, unit vector is k cap. Free vectors are those vectors which can be displaced parallelly anywhere, and by doing this there will no effect on the vector. Like we have a vector this a vector. If I displace it without changing the direction and magnitude, and by doing this, if there is no effect on the vector, then this is called free vector. Localized vectors are those vectors for which the line of actions and the position are important. It means we can't displace them from their position. And coplanar vectors are those vectors which are lies in same plane, like these three vectors are coplanar vector as they lies in same plane. One dimensional, two dimensional and three dimensional vectors. One dimensional vector. In this vector we have only one dimension which can be x, y or z. Let our vector is along the x axis and this is r vector. Then how can we write this? R vector equal to, as I have told you earlier, vector can be written as the magnitude of the vector multiplied by unit vector. So here the vector is along x axis, so the value will be only x coordinate. Let this is small x, and along this axis the unit vector is I cap. So this is the value of r vector. If the vector is along y axis, then this can be written as y j cap. If the vector is along z axis, then this vector can be represented as z k cap. In two-dimensional, vector lies in a plane. Let our vector is in xy plane. This is our vector r vector. Since the vector is in xy plane, so this point will have the coordinate x and y. Now the vector can be represented as, since this have two values x and y, so one value is x and along the x the unit vector is I cap, one value is y and along the y the unit vector is j cap. So this is our vector. If our vector lies in yz plane r vector, then this can be written as r equal to, we have y value, so y j cap plus z value, and along the z unit vector is k cap, z k cap. If our vector is along the, if our vector lies in xz plane, then these vectors can be represented by x I cap plus z k cap. If we have three-dimensional vector like this, then this will have three coordinates x, y and z. So vector can be written as x I cap plus y j cap plus z k cap. Position vector. If a vector represent the position of any particle, let the particle is p, then the vector representing the position of this particle is called position vector. X-axis, y-axis and z-axis. This position vector can be written as x I cap plus y j cap plus z k cap. If we want the magnitude of the vector r vector, then this can be found as square root of x square plus y square plus z square. Now let's talk about displacement vector. If a particle is at point A and have position vector r1, and after a certain time it moves from A to B, so it displaced from A to B, and at point B it have the position vector r2. Then this AB will called displacement vector and written as del r. Since displacement is find by the final position minus initial position, so r2 minus r1. Now write the value of r2 and r1. Since r1 is x1 I cap, y1 j cap, z1 k cap, and r2 is x2 I cap, y2 j cap and z2 k cap. If we write this value here, then we get x2 I cap, y2 j cap, z2 k cap minus x1 I cap, y1 j cap, z1 k cap, or del r vector displacement vector equal to x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. If we want the magnitude of the displacement vector, then this can be found by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Combination of vector. Before combining two vectors, we have to know that we can displace any vector without changing the direction of the vector, and only vector addition can be done in same physical quantity, like the vector of velocity can be added in vector of velocity. When two vectors are combined, then we get a one vector which is called resultant vector. For combining vectors, we have three laws: triangle law, parallelogram law, and polygon law. In triangle laws, if two vectors are represented in magnitude and direction by two sides of triangle taken in cyclic order, then their resultant will be represented totally by third side of the triangle taken in opposite order. Like we have two vectors, A vectors and B vectors, and we want to combine them using triangle law. Since we can displace the vector without changing its direction, so I can write this here, B vector, and the third vector taken in opposite order. If I move in this way, then this will be cyclic, but third side should be taken in opposite, so this will be taken in that way. In this case, this third side of the triangle will represent the combination of A vector and B vector, and this is our triangle law of combination. In parallelogram law, if two vectors are represented by two adjacent sides of a parallelogram, then the diagonal comes out from the point of their intersection will represent their resultant vector. If we have this vector and we want to combine them by using parallelogram law, in the triangle law, both vectors are added like this. Tail of one vector will place on head of another vector, and in parallelogram law, the tail of both vectors will be joined together. So, if this is A vector, then B vector will be taken along this. Now, make a parallelogram. Now the diagonal coming out from their intersection will represent the resultant vector, which can be written as R vector equal to A vector plus B vector. And in polygon law, if two or more than two vectors are represented by the successive sides of a polygon, then the last side which closes the polygon will represent the resultant vector taken in reverse order. We have a vector A vector, B vector, C vector, D vector, E vector. Here 1, 2, 3, 4 and 5. These 5 vectors are taken in successive orders and represented the side of a polygon, and the last side which is taken in opposite order will represent the resultant vector R vector, and this R can be written as A vector plus B vector plus C vector plus D vector plus E vector, and this is our polygon law. In next class, we will discuss the mathematical method of the combination of vector. This is the graphical method.